So now that we have integrated our Starfield into Spacefighter, in this video we're going to take a look at setting up a restricted view play area for Spacefighter.
The reason we'd want to do this is this follows the common technique in this genre of game, which dates back to the original hardware cabinets on which these types of games were usually played. On a lot of the original arcade hardware, you would have a CRT monitor that was flipped over on its side. This meant that you had a playing area which was taller than it was wide. And this gave several advantages in this style of gameplay in that you could see enemies more quickly in the future, and you had less area to cover left and right. So it simply catered to the gameplay.
Okay.
Now on the PC platform, we don't have the luxury of taking our CRTs and turning them over on their side, so what we're doing to simulate this effect is to set up our screen area and divide it up into you can call it a view region or a viewport that is narrower than it is tall, and this will of course leave bars, void regions on the sides of the screen, which will fill with a color to indicate that you can't move there. And these filled areas of non-play regions make good places to throw information.
Exactly. Now, the way we're going to go about doing this is going to be, well, very straightforward. If we were to take the time to create a true game that we were planning to market, we'd probably spend quite a bit of time thinking about a viewport class and giving ourselves a lot of flexibility and control so that we can then employ that particular class in all games that we create in which we need control over the viewport region. But in this particular case, we're just going about setting up a very simple, restricted playing area. It's very easy to do. It's really going to go quite smoothly for the way that Spacefighter has been written. Everything has been constructed based off of a screen width. So all we need to do is redefine our screen width. So let's spend just a second and let me see if I can draw out an area to
add to what you were saying about the idea of the fact that we could make a viewport class that would generally allow the play region to be different than the overall screen resolution. One reason that we're not doing that is the fact that we can accomplish this entire process by essentially just creating two new fields.
Yeah.
So, I mean, yes, you could encapsulate everything and make it more future-proof for different games, but in the case of Spacefighter, the trade-off is two fields will give you the desired result. That is a restricted area centered on the screen, and everything else can be calculated from that new width.
Now, SW that I just drew up there represents our current screen width that everybody should be familiar with, and we're using it all throughout Spacefighter at the moment. But what we're looking to do is to come in here and define a new area. This new area is going to be our view width. That's going to be this area right here. So in this video, there's three major things that we need to look at doing. Number one is redefining our screen width to our view width, and then coming up with a new screen width that really does represent the true width resolution of the entire game, not the playing area, but the entire game, because we need that in our constructor for the game. And then we need to basically make sure that sprites take into the account that that's not really 0, 0 anymore as far as our playing area is concerned. That's kind of right here now. So we need to take that into account with drawing. And then finally, we need to just simply fill in these regions out here. So very first thing is setting up this new view width and then refactoring our screen width.
Now, at first that might sound a little bit odd, because earlier you were describing this as we're going to take screen width, we're going to change it into view width, but then we still need screen width because we still need to tell the graphics device how wide the screen is.
We do.
It seems a little bit backwards, but the cool thing is that this allows us to use refactoring to hit all of the places in code that require the width of the screen in order for gameplay.
So in about 15 seconds, we'll have everything updated.
If that.
Exactly. If we take our time and talk about the weather or something. But we will need to, after refactoring for view width, we will then need to create a new screen width.
And once again, that's because the graphics device does indeed need to know how wide the resolution for the screen is.
The next thing we're going to need to do is take into account sprites.
And where this comes in is the fact that we can narrow the screen width. Basically, if we change screen width into view width, and we make view width more narrow, we can indeed make a narrower bar. The problem with that bar is there is no offset. What we would have is a narrower screen area that is on the left side of the screen. So we'd have view play on the left and display or HUD information on the right.
Right.
Which you could do, but in my opinion doesn't look as nice. It's nice to have the view width centered on the screen instead of on the left side of the screen. Now what that means is basically just taking that new view region and moving it to the right until it's centered. But we need to know that offset. What is the offset to go from the left-hand side of the screen to be centered on the screen?
It's very easy to calculate. I mean, if you just look at screen width right now and you say, all right, give me half of screen width, that's going to take me all the way down to there. And then if I say, all right, let's subtract away from that, so we're moving back in this direction, 1/2 of our view width, well, our view width goes from here to here. So if we subtract half away, wow, how convenient, that takes us back to right there. So that'll put us up there.
And the other interesting thing about the way that we'll use this new offset to move the origin from the left-hand side of the screen to the left-hand side of the view region is the fact that this offset is only going to be used when drawing sprites. It's not going to be a consideration when positioning them, and that makes it more convenient as we can still use an origin of 0, 0. So that means we could still create a sprite at position 0, 0, but then we would see it at the left of the view region instead of the screen region. And the benefit there is the fact that we don't have to go through and update all of the positioning everywhere in Space Fighter.
That's right. And the final thing, like I said, is that we need to fill in our margins, if you want to call them.
The idea there is that the current background to the game is that star field, which is relatively dark and wouldn't give a very clear line of where the screen borders exist. If we take the non-playable areas of the screen and simply fill them in, then it makes it very obvious as to what is playable and what is not playable.
And we'll, of course, procedurally do this, but I'm sure many of you out there will simply reach for some of your own custom graphics. So we'll basically block in these areas, and then we'll turn around on top of that and we'll give a nice line just to kind of really make our playing area stand out. So that's everything we have planned in this video, and let's get started.
All right, let's switch over into Visual Studio, and let's get started. We need to first go over to config because it is inside of config that we have the original screen width value. And as we discussed on the whiteboard, this needs to become view width so that we can restrict it. If this magically becomes view width, then everything it uses screen width just goes along with the new value. We'll change this over by refactoring it. So we'll move the cursor over to screen width, hit F2, and let's refactor screen width to view width. We'll hit OK to that. Now before we go through and change everything, there is one place that I'd like to remove the screen width from, and that is inside of the constructor. So inside of game 1, inside of the where graphics preferred back buffer width is set to screen width, we'll remove that one because we would, if we change that one in refactoring, we'll have to change it back to screen width later. Everything else, however, we'll leave set. We'll hit apply, and now screen width has been screen width has been refactored to view width. Now view width needs to be more narrow than the overall screen, so we'll change it to a value of 450 pixels. Now that we've changed view width, though, we really do need a screen width value. So I'm going to put a new field into place called screen width, set to a value of 800 pixels. And now if we jump over into the game, we should be able to confirm that the config.screenWidth is in fact something accessible inside of config. So we have kind of very quickly pulled the rug out from under screen width, changed it to view width, and then re-added a new screen width value. Now, we also need to have our offset in place so that the origin can visually line up with the screen width, and we need so we can basically move the new view region off the left side of the screen into the center of the screen. And we'll do that with a value called screen left. This will be a public static integer called screen left, which is set to a value of screen width divided by 2, so the center of the screen, and then we'll subtract from that, so we'll move left by the amount view width divided by 2. So half the viewport's width subtracted from the screen width should give us a value at the screen left. We can also view screen left as the new origin for all sprites. Now, we also need two values to describe the colors that will be used when we draw these margin bars on the left and right side of the screen, so we'll drop these in as well. We'll make public static color fields The first will be margin color, and this will be the main fill color. That will be a new color with the RGB values of 64, 64, 74. Again, this gave an off-gray color kind of tinted to purple, and this was simply found by trial and error, as opposed to using any of the predefined colors. I can duplicate this color field now, and we can make a field called margin edge color, because again, it's shown on the whiteboard. So margin edge, we're going to highlight the edges of the screen just for added visual effect. These values are going to be 128, 128, 148. Alright, now we should have all the information necessary to work with the screen and draw the margins. Now let's go through a few of the different places in code where we need to take some of these values into account, beginning with the sprite class. Inside of sprite, we need to make sure that sprites are drawn with the offset in mind. So the easiest way we can do this is take this incoming position and increment it before it is used here in the call to spritebatch.draw. So we'll do this by saying position plus equals new vector2, and that vector2 is going to use config.screenLeft for the x component and 0 and y, meaning we're not going to adjust or offset the position in y at all, we're simply offsetting in x. And this means that visually sprites will have their origin offset to the new view region, but in actuality, for things like positioning or node positioning, we can still use 0, 0 as the actual code origin. Alright, from here, we should be able to start testing things, because view screen left should be properly calculated based off of the screen center. Everything should be refactored. Let's build at this point, make sure that there are no errors, and see what the result is so far. Well, we can see that the star field is drawn on a narrower plane, but the player doesn't seem to, or excuse me, the star field doesn't line up with it. Watch what the player's extents are. We can go from that range over to the right. We'll also note that we're not seeing any asteroids on the very far right or very far left side of the screen. Now again, when we draw the margins, this will be more apparent, because you could just say that maybe the randomizer hasn't hit the edges of the screen yet. But one glaring thing that's actually throwing things off, making it hard to see, and something that has to be adjusted is the star field. It is still being drawn from the far left side of the screen. So let's go into the star field class. The star field has a draw method which is basing it at a value of 0 in x. We can replace this value with screen left. So if we look into config and grab screen left for both of the drawing scenarios for the star field, we can see that the star field is now centered in the screen and gives a much better indication of where the play area actually is. And of course, this has all come along with no adjustment to any of the actual game code. 0, 0 is now over on the side, and all of our existing positioning works, including the level zone view center.
Very nice.
Moving on from here, we now need to fill in those margin areas, because once again, those are plain black, and the star field is over a background of black, so it's still not overly clear where the edges of the screen reside. So what we'll do is we'll go into our game class, and we'll make a fill texture. Basically, in order to draw the bars on the side that represent margins, I'm going to use a 1 pixel by 1 pixel texture. And to avoid having to draw and import a 1 pixel by 1 pixel texture, we'll simply create one procedurally in the load content section of the game. Now we will of course need a texture field to hold this in, so inside of the game class I'm going to make a texture 2D field called fill texture. Then inside of load content, right after we've created the star field, we can create the fill texture. So fill texture will be equal to a new instance of texture 2D. We're going to need to feed in a graphics device, the width and height of the texture, so we'll make this 1 by 1, the number of levels to be used in conjunction with the texture when mapping. We'll specify only 1. There's no reason to make a smaller version of a 1 pixel by 1 pixel texture. The texture usage is going to be none, so no considerations into how this is drawn via hardware. And finally, the surface format is going to be color. This makes it very convenient as we can treat the individual pixel values, the individual byte values, as actual colors. So now that we have a new instance of fill texture, we need to take that one uninitialized pixel and set it to a value of white. We can accomplish this to a call, or with a call to set texture, or excuse me, set data for the fill texture. So we'll call fill texture.set data. We'll specify color for the type, and the information needs to be a color array. Now instead of making a separate color array variable, I'll simply make a new color array right here inside of the parameter, and then specify the element as color.white. Now we don't need any additional variables. We'll just specifically set new pixel to be a value of white. And that may be considered kind of a roundabout way of drawing a 1 pixel by 1 pixel texture, but it is purely procedural, and it does alleviate us of having to import more textures. Now, down inside of draw, we can draw the bars over the screen after the nodes have been drawn. I'm specifically going to draw these after the nodes so that if a node is half off screen, because if you remember, the origin of 0, 0 being half off screen, since sprites are centered around their origin, means that originally, if an asteroid was on the far left side of the screen, you would actually only see half the asteroid. We want the same effect here. We don't want to see the asteroids overdrawing the bars. We want the bars overdrawing any of the game nodes. So after the nodes have been drawn, but before any of the text has been drawn, we'll drop in some lines to draw these padded areas, these rectangles, which will fill out the margin. So let's begin with the rectangle that will draw the left margin. So we need to start in the top left-hand corner of the screen, go up until the screen left, and then draw the entire screen height. So let's make a call to spritebatch.draw. Let's feed in the fill texture for the texture2D parameter. Let's give a new rectangle for the rectangle to draw as the destination rectangle. In order to start at the top left corner of the screen, we'll give 0 and 0 for x and y. For the width, we want to go basically from 0 up until screen width, or excuse me, screen left, because screen left starts the left-hand side of the view region. So this will be config.screenLeft. Height will be config.screenHeight. And that should take care of the new rectangle. The final thing to give is what color to draw the fill texture as. We've set up 2 margin colors inside of config, the first of which is simply margin color, and we'll put that into place here. Now if we run, we can see that the left-hand side of the screen is drawn in a gray, off-gray color. So now we have our information on the non-playable area, and we can clearly see what the non-playable area is. But now we need a bar of the same nature on the right-hand side of the screen. I'll start by copying this line for drawing the left margin, paste it to duplicate it, and we'll change the parameters given to the rectangle to change the coordinates where it's drawn. We want to start with a rectangle that's going to draw in on the right-hand side of the screen. So that's going to be config.screenLeft. So if we start at, let's remove this from our width, put it in our x. So what would that do? Well, that would start x. That would start overdrawing the actual playable area. So we want to offset this by config.screenWidth. So basically we move to the left side of the view width, but then if we offset by the view width again, actually that should be view width. So we move to the left of the view region, move the whole width of the view region, and that leaves us at the right side of the view region. The start in Y is going to be 0, so once again we start drawing from the top of the screen, and we need to draw for a width.
That's the screen left again. We can just reuse that particular width on the right-hand side.
Right, because if you look at the amount of space between 0 and screen left, that gives a specific width.
Exactly.
If we use that on the right side of the screen, it's still the same width.
Yep.
So the width will be config.screenLeft. The height will be config.screenHeight, once again to get the entire screen, and we'll use the same margin color.
Cool.
Now if we run, there's our margin on the right side. So now we have the non-playable areas, non-playable regions clearly indicated. One final thing I'd like to do, though, is to draw a highlight, a margin edge, just to make everything look a little bit better, because right now everything looks very flat. We just have these gray boxes that are there for seemingly no reason.
Mm-hmm.
So to draw these margin edges, I'm going to grab a new, or rather duplicate one of the existing lines. To begin with though, to avoid confusion, I'm actually going to pull all of the parameters to 0, so we're drawing a rectangle of no width and height at 0, 0. And we'll begin with all of the offsets. We'll also change the color here to margin edge color right off the bat. So from margin color to margin edge color. And now we can focus purely on the coordinates. So the x component of that rectangle is going to be the screen left minus 1. Because right now we're drawing all the way out to screen left. So what we're actually going to do is overdraw the rightmost pixel of that first box. So let me comment out this line. I'll just try to lightly point with the mouse where this edge on this side of the margin needs to be overdrawn with a highlighted pixel. So that's going to be a value of screen left. So config.screenLeft, but minus 1, because if we leave it screen left, we're actually going to start at screen left and draw one more pixel to the right, so we would actually be overdrawing the playable region by 1 pixel. Now again, that's a very fine amount of space, but it's nice to keep everything lined up so you're drawing what you're expecting to draw. Now, the Y value can be a value of 0, starting at the top of the screen. The width can be a value of 1, and the height needs to be the overall screen height. So we can simply steal config.screenHeight, put that into place. Now if we run, we see we have a highlighted line on the left edge of the screen, clearly indicating where the left edge of the screen is.
It looks very nice.
Now we can copy that line so we can draw for the right side, or the right edge margin. And so what we'll do there is we'll take the screen left plus the view width, so just in basically the same manner as we did here, and we don't actually need a further offset because we started at this point and then drew the whole box. We can start over at this point and draw 1 pixel to the right, and we're overwriting into the margin, not overwriting into the gameplay area. So overdrawing starting here on the right side of the margin. Again, the start value in Y is going to be 0, starting at the top of the screen. The width is going to be a value of 1, and the height is going to be a value of screen height, giving a result of highlights on both edges of the screen.
Very nice.
Now, if you would like, you are, of course, free to simply use graphics that fit this area instead of procedurally generating everything. The thing I do like about the procedural method is if we change any of the parameters, screen resolution or view width, we have the automatic borders drawn in. We don't have to worry about adjusting graphics. But really, I think that brings this video to a close. Again, the topic covered here was making a view region that is separate from the overall screen area. And really, I believe this is probably the first time we've addressed this problem in the XNA class. Because this is the first time we've separated the idea of playable region versus overall drawn region.
Right.
So we've done that by making a view region, which is really just a width that is less than the screen width. Then we went on to create all the necessary parameters to visually offset all the sprites while leaving the logical positioning the same, and then simply drew some margins, filled in the margins to indicate where the view region was. So with that, that wraps up this video.
Thanks a lot, everyone.